So in this video we'll be going through distance time graphs, also known as travel graphs, and finding out the speed from a travel graph as well as describing a time distance graph. And let's get straight to the lesson before I get shut down for the terrible joke that's on the screen. Now, a travel graph shows information about a journey, and time graphs are also known as time distance graphs or distance time graphs. Now, travel graphs show the main features of a journey and use average speeds, which is why the lines in them are straight. Now, in reality, the vehicles do not travel at constant speeds because obviously they slow down when they're coming to the end of a road or speed up as they're leaving the end of a road, etc. So generally, rather than having like a massively curvy up and down graph, what they would tend to do is just represent constant speeds rather than actual speeds. And how we calculate the average speed is given by this formula, as you can see on the screen, which is speed equals distance divided by time. Now that is definitely something that is definitely worth noting in your notes of this formula, and is a formula that you are going to need to know and remember. And we will be recalling it when we go through some example questions. Now then, a couple of other things to note are the following. So in a time graph or a time distance graph or a distance time graph, the steeper the line, the faster the vehicle is traveling. And obviously that applies to the diagonal line. So the steeper the diagonal line, whether it's going upwards or downwards, represents the speed of the vehicle. Now any horizontal lines mean that the vehicle has stopped or is stationary. And any lines going in an upward direction means that it's going further away from the starting position, and a line going in a downward direction means that it's getting closer to its original starting position. So for example, here we can see a typical distance time graph, and obviously our distance is measured in kilometers, which again is something that's definitely worth noting, is the units of both your distance and your time, and the time is represented by hours. So what I can note here is that this point of where your time distance graph starts, that there is my starting position. So you could say that's like starting at home, but that's basically where you're starting at that. Now your starting position could be home, it could be school, it could be anywhere that you're originally starting from. And what we're doing is we're heading out away from our distance. So in terms of describing what each of these things are, so AB is basically traveling, and it's traveling 12 kilometers and it's taken 3 hours away from the starting position. Now representing B to C, now because that's stationary, that means that the vehicle has stopped. So here it's basically stationary or stopped, depending on the type of vocabulary you want to use, for 1 hour. Now when you are describing a journey, you definitely want to include those 2 points. You want to describe the distance and the time. If it's going up, then it means it's going further away. If it's going down, it means that you're returning or getting closer to your original position. And then CD is then heading back. So heading back, and it's traveling, and it's going to be 1 hour traveling and the distance is going to be 12 take away 6, which is going to be 6 kilometers. And then D to E, again, we're stationary. So again, it's stationary for 30 minutes, because the reason why it's 30 minutes is because it's half a square. And then E to F is then traveling back, which lasts another 3.5 hours, for 3.5 hours, and it's for traveling and the remaining distance is going to be 6 kilometers. And there we go. So you can see that this here, so upward, a line that's going in upward direction, so this line that we can see here, which I'm not doing very well in terms of tracing, there we go. So this line here is travelling away from our original point. Our stationary points, which are here and here, which means that the vehicle has stopped, and then we're going back to our original point because the lines are going downwards. Now, a question that you typically could ask is, at which point are you traveling the fastest? So here we're not looking for the upward line or the downward line. Here we're looking for the steepest line. So think about which would be the most dangerous to either climb or to fall down on, which sounds a bit tragic, but you know what I mean. So here we're looking for which is the steepest line that we're looking at. So out of the 3 diagonal lines, either the blue or the red, which sections are the steepest line? Well, the fastest will be CD. So here, CD, between CD is the fastest. And then which out of the 2 lines, which is the, let's say, less steep line, or a flattered line, should we say, and that would be E to F. So we just get a different color. Let's go for pink. So this would be the slower. Now let's use a different color pen. That's better. And so it would be the slowest traveling will be here. So which is E to F. And there you go. So let's now have a look at actual calculating speed. So again, this is a very, very common question you could get asked. So in terms of calculating speed, so the speed is calculated by finding the gradient of the line. Now the gradient is basically a calculation that measures the steepness of a line. Now to do this, what we need to do is pick 2 coordinates. You then turn this into a right angle triangle. And then the third step, which is most important, is using the scale. And I'll explain to you what that means when we go through some examples, is find the base, which is going to be the time, and finding the height, which is going to be the distance. And then we use the formulas previously mentioned, that the speed is equal to distance divided by time. And then obviously we then need to write our units. So let me have a look and go through these 5 steps, just so you get an idea of what it is I'm actually talking about. So with, well, let's number these. So let's go for 1, 2, and 3. Now, in terms of looking at this, so the first thing we notice is we've got a graph. Now, what I want to do is I want to pick 2 nice coordinates. So I'm going to go for this coordinate here. Now, it doesn't matter which coordinate you go for, but you want to try and pick one where it's easy to read the numbers. So I'm going to go for this point here, and I'm going to go for this point here. Now, because the lines are straight, it basically means that it's going to go at constant speed. So it doesn't really matter what 2 coordinates you pick. Because it's all on the same line, it's going to be absolutely fine. So I've picked my 2 coordinates. So the next thing I then need to do is turn that into a triangle. So here what I'm going to do is I'm going to turn that into a right angle triangle where the line acts as the diagonal. So there is my right angle triangle. So then the next thing we then need to do is to work out the height. Using the scale is work out the height and the base of that triangle. So let me get the red pen. So here we can see that the base is 3 hours and the height is going to be from 0 to 150. So that's going to be 150. So the key thing to remember here is we're not calculating the squares. We're not counting the squares going across and up. What we're doing is we're using a scale to work out what the height and the base of that triangle is going to be. Now the last thing we now, or the 4th step we need to do is now using these measurements, we now need to use the formula of speed equals distance divided by time. So for question 1, what we've got is we've got 150, so speed equals, and it's going to be 150, which is the distance, divided by the time, which is 3. So then the speed is going to equal 150 divided by 3, which gives me 50. Now in terms of the units, well, you can see that the distance is measured in kilometers and the time is measured in hours. So what that then means is that I'm going to be using the units of kilometers per hour. And it's entirely up to you which one you want to go for in terms of that. Now, again, you could put it as a slash, or you could write kilometers per hour. Now, when you're looking at speed, this kind of tells you, is a reminder of what formula you need to use, because kilometers per hour or miles per hour, again, per just means divide. So this is your distance, this is your time, and you are dividing. So again, it's a nice little quick way of remembering that formula. So let's have a look at number 2. So again, I'm going to pick my two coordinates. I'm going to go for two nice coordinates I can read off. So I'm going to go for this one and this one here. So again, I'm going to turn that into a right angle triangle. Oh, completely messed that one up. Let's try that again. Like so. Now, again, let me go through this question and I'll explain to you how it all works. So here, the height is going to be 200 and the base is 10. So here we're looking for number 2. We're looking at speed is equals to 200 divided by 10. So the speed equals 20. And then the units are going to be, I'm guessing M could either be meters per second or miles. We don't really know. So we're going to go for M and then per second. So /8 and there, S, and there is our final answer. Now let's say I pick two different coordinates and let's see if we get the same answer. So let me continue with question 2. But this time, let's say I'm going to go for this point here and this point here. So again, I'm going to draw my triangle. So in terms of looking at the base, I'm going from 5 to 20. So that's going to give me 15. And here I'm going from 100 to 400. So that's going to be 300. So if I then do 300 divided by 15, I still get 20 miles or meters per second. So you can see that it doesn't matter how big your triangle is or how small your triangle is, because you're using the same line as the diagonal on your triangle, you will always get the same answer. So again, try and go for as big as possible, but make sure your points are on the line that you're actually wanting to find. And then finally, for question 3, so again, I'm going to pick two coordinates. I'm going to go for this one here, and let's go for a nice coordinate. Well, I'm going to struggle to find a nice coordinate, so let's go for this one here. So this one's a little bit fiddly. So again, I draw my triangle here. Now, ideally, what you want to try and do is pick one where it's an actual number. But for this, we can work with it. It's not a problem. So here, in terms of the time, so every little slash means half an hour. So that's going to be 1.5. And then for the time, I make it to be from 0 to 12. So that's going to be 12 there. So the speed, so for number 3, the speed for this is going to be 12 divided by 1.5. And so S is going to equal how many 12.5s, how many 1.5s rather, going to 12. And that's going to give me an answer of 8. Now again, looking at the units, I've got hours and I've got miles, which kind of goes back to this one being meters. So here it's going to be miles per hour, or I could write it as 8m /h/r. So again, it doesn't really matter how you're going to write it, it's entirely up to you, but there is your final answer. So what we're going to do now is look through a typical question you could get asked based around distance time graphs. So here we're returning to a familiar graph that we looked at earlier, but we're now going to relate it to a particular situation. So this question reads, Jamaica went for a walk. Her walk is represented by the graph. And the first part then says, is describe the part of the walk represented by C to D, D to E, and E to F. So if we have a look at what this is, now we're just going to assume that this point here is home. And she's going for a walk, and we don't know what each of the parts are, but we just know that our starting point is home. So she goes away from her home, and then she stops for a bit, and then she goes back. And we don't know what that is, but we'll just go from there. So in terms of describing the parts, so C to D is that she is, now in terms of looking at the distance and time that she's travelled, it'll be 12 take away 6, so she's travelled 6 kilometres, and she's travelled for 1 hour, and that she's travelling on her way back, on her way back. And then from D to E is she then stops for half an hour, and again, no indication of what she's doing in terms of direction, she's just stopped. And then E to F is she then continues on her way home, and she's travelling for 6 kilometres, because we're doing 6 take away 0, so it's 6 kilometres, and it's taken her 2.5 hours. to get back. And again, she's on her way back. So that is what you generally write for part A. Let's use different colour pen. There we go. And then for B, the question then says, on which section of the walk does she walk the fastest? So here what we're looking at is we're looking for the parts of the line that has the steepest lines. So the steepest line. In other words, we're looking for where it's got the greater gradient. So we kind of already mentioned this previously in the video, and the bit that's got the highest or the fastest that she's travelled is going to be from C to D. And then finally for C, it says what was her average speed for the first 2 hours. So here I can't pick the triangle because it's specified it's looking for the first 2 hours. So if I just draw the first 2 hours of the line and then I go upwards, so this blue triangle is what I need to do to work out her average speed. So again, speed is equal to distance over time, and the distance of that triangle is going to be going to 8 kilometers, and the time it's taken is 2 hours. So I do 8 divided by 2, which is going to be 4, and then I don't forget the units, which is kilometers per hour, and there is your final answer. So let's have a look at another example. So here it says the graph below, or the graph on the side I should say, represents the journey of a steam train. The vertical axis represents the distance from the train station, from the station in kilometers. Okay, so here is our time distance graph. So the first question asks, how far did the train travel in the first 40 minutes? So here what we need to do is find our 40 minutes, which is going to be here. And all we need to do is just read off the vertical axes. So for A, the train's travelled and it's going to be 10 kilometers. And then for B, it says work out the speed of the train between A and B. So again, if I just rub out those lines so it's not confusing, let's pick a different colour. So for A to B, which is from this point here to this point here, so again, I draw my right angle triangle between those points. And we need to, and the question says to give our answer in miles, kilometers per hour. Right, so in terms of when we're looking at the distance, so here it's traveled 10 kilometers. Now here it's traveled 30 minutes. So here 30 minutes, and that equals 0.5 hours. Now it's really important that we look at converting time because it specified what units to use. So we need to make sure that as it's in kilometers per hour, our distance is in kilometers and our time is in hours. So that's what I've done there. So now once that I've done, I can then use the formula and substitute the values in to work out the speed. So here I've got 10 divided by 0.5. And if I work that out, I get 20, and the units are going to be kilometers per hour. And there it is. And then finally, for question C, it then says, what does DE represent? So DE, which is here to here, and that basically represents the, and let's just go back to, is basically the return journey. So C is the return journey of the train back to its original station. And there we go. And finally, looking at this particular question, those of you who watch The Office might recognize this name. So here we've got Dwight went out walking. People are usually walking or taking a car or train ride. The diagram represents part of his walk. After walking 9 kilometers, Dwight turned round and walked straight back to his starting place without stopping, and it took him 2 hours to get back. So the first part's asking us to draw a line on the grid to show this. So as he's walking back, we know that the line is going to be going downwards. Now in the clue in the question, it says that it's going to take 2 hours for him to get back. So what we need to look at is how many little squares represent 1 hour, which is going to be 4. Get it? I make it 4. So from here, which is at 4 o'clock, which is where he got to his where he got to his peak of his walk, shall we say. He travels 2 hours, so it's going to be 6 o'clock return. So what I need to do is join that point there. Let's just go with this point here. I'm traveling 2 hours, so what I'm going to do is I'm going to try and use a ruler and show a bit of good in terms of making a good point of using a ruler. And we're just going to connect those points up, and there we go. And there is my return journey. Now the next question then says for B, says work out the average speed of the return journey. So again, what I'm going to do is I'm going to pick my 2 coordinates of the start of the return journey and the end of the return journey. And again, I'm going to turn that into a right angle triangle. And then again, I need to work out the height in terms of the kilometers. So it's going from 0 to 9, so that's 9 kilometers. And the time difference is 2 hours. So to work out B, the average speed, or just the speed, is going to be equal to 9 kilometers divided by 2 hours, which is going to be 4.5 kilometers per hour. And there is our final answer. So the key thing here is to make sure you're writing the units and checking the units. And whenever you are working out the speed, just double check. When you're drawing a triangle, it's not how many squares, or sometimes it might be, but always check with the scale to make sure you're using the right numbers of the height and the base of the triangle that you're using. Now there will be a copy of the exact same questions I've worked through in the description below for you to practice, along with another worksheet for you to test your understanding of this video.